Welcome to Mrs. Miller's notes for her double block algebra class. These are the notes for section 7.2 entitled Solving Linear Systems by Substitution. And today we're going to solve a system of equations, but we're going to use the substitution method instead of the graphing method that we saw in the previous section of notes. Now the substitution method is a little bit nicer than graphing because you don't have to graph, but you may still have to solve at least one equation for a variable. Now, you want to try and see if there's an equation that has a variable by itself. That's the first step here. And by itself, I mean like it's 1x plus 5y equals 20. Or it's 3x plus 1y equals 15. So you want to have a 1x or 1y. So that's the variable that we're going to look for. And then you want to solve the equation for that variable. Then you're going to take that equation and put it into the other equation. And that's the tricky part, is putting an equation into an equation. But then when you do that, you'll be able to solve for the variable that's left over. The whole point of doing that is so that you have one variable that you're solving for. So after you solve that equation, you'll have x equals 5, let's say. Then you can substitute that value into either one of the other original equations to solve for your other variable. So if you know x, you can solve for y. Or if you know y, you can solve for x. And then we want to check our solution. We want to substitute it back into both equations and make sure it works. Okay? So that's kind of a wordy process there. So we'll go through a couple examples here and actually do this by hand so you can see what it looks like. So example 1, we have an A and a B, and then there's a C on the next slide as well. And part A is kind of a nice, straightforward substitution equation because it already has a variable that's solved for. This top equation here, S equals T plus 4, that's already solved for a variable. It's already solved for S. So then I'm going to take what S is equal to, this T plus 4, and I'm going to substitute it into the other equation where the S is. So I'll still leave the 2T, but instead of having plus S, I'm going to write what S is. T plus 4 equals 19. Now I have one variable. Now, granted, there are two of them. There's a 2t and a 1t, but they're all t's. I don't have a t and an s. So now I can combine my like terms there. So I'll have 3t plus 4 equals 19, and then I can finish solving this equation for the t. So I'll have 3t equals 15, and when I divide by 3, t will be 5. So there's one of my solutions already, and I haven't graphed anything. Now I still have to figure out what S is, so I'm going to go back up here to either equation. You pick the one that you think is easier. I like the top one, and it says S equals T plus 4. Well, now I know what T is. T is 5. So instead of T plus 4, it's going to be 5 plus 4. So S equals 9. There's my other solution. Now before I completely walk away from this, though, I have to write my answer as an ordered pair. And if I'm not dealing with x's and y's, or even when I am dealing with x's and y's, remember your ordered pair goes alphabetically. So S comes before T in the alphabet, so 9, 5 will be my solution for my ordered pair. Now I want to check this and see if it is a true statement for both equations, just like we saw yesterday. So I have T is 5, 5 plus 4 equals 9, S is 9, okay. Then I'm going to check it in here. 2 times 5 is 10, plus 9 is 19. There we go. It works in both equations. Okay, so we're going to try that again in part B, except part B has an extra added little step. I don't have an equation that's already solved for a variable. So this one I'm going to have an extra step that I have to do. But I have a choice, okay? I want to look for the equation that has a variable that's by itself. And here, this equation has an x and a y that's by itself. Even this minus y or negative y could be by itself. We could solve that for y, okay? But I'm going to solve for either x or y. And let's just say, let's solve this top equation for x, okay? So if I do that, I have to subtract the y over. So x plus y equals 4. So I'm going to minus the y over. So x equals, and you can write 4 minus y or negative y plus 4, doesn't matter. So all I did was I rewrote this equation in a different form. So that's the exact same as this other equation. But now it's solved for x. So now instead of writing x in this other equation, I'm going to substitute the stuff that x is into this other equation. Now you have to substitute it into the other equation. So if I solve this top one for x, then I can't put it back into itself. That's kind of like plugging Christmas lights into themselves. They don't turn on, okay? So I have to take this 4 minus y and substitute it into the other equation where the x is. So if I just wrote negative 2x minus y equals negative 5, I don't want the x anymore. I want to write what the x is. And the x was 4 minus y. That's how we substitute one equation into another equation. Okay, so now I have an equation that just has y's and numbers, so I can solve this for y. I'm going to distribute here, so I'll have negative 8 plus 2y minus y equals negative 5. Then I'll have negative 8 plus y equals negative 5. When I combine my y's together, 2y minus 1y is a y. And then I will add the 8 over to the other side. So y equals 3. Okay, now I can take this value and I can substitute it into any of my other equations to get x. I can substitute it into the original top equation or the original bottom equation, or I could even substitute it into this one in the box here, the one that I resolved for x. And that's actually what I'm going to do, because this is already solved for x. So x equals 4 minus y, which is 3, and 4 minus 3 is 1. So my ordered pair then for my solution is going to be 1, 3. I want to check it, make sure it works. So 1 plus 3 is 4, okay. And negative 2 times 1 is negative 2, minus 3 is negative 5. There we go, it works. Okay, so let's try that one more time. Now this equation is, or this system is probably the toughest of the systems of equations that we've seen so far. And I say that because there's lots of coefficients in front of our variables. I have a 3x and a 5y and a negative 2y. The only equation that has a variable that's by itself is the bottom equation. And that's for the x. The x is by itself, meaning it's just 1. It's 1x. So that's the equation that I'm going to solve for. So I'm going to solve that equation for x. So x minus 2y equals negative 10. So I'm going to add the 2y over to the other side so I can solve for x. 2y minus 10. So now this equation here is the exact same as that equation there. It's the same one. They're exactly the same. I just rewrote it in a different form. But since I solved it for x, I have to put it into the other equation where the x is. Again, remember, we have to put it into the other equation. We can't put it back into itself. We can't substitute an equation into itself. Okay, so instead of having 3x plus 5y, equals 25. Instead of that x, I'm going to replace it with the stuff that x is. And x is 2y minus 10. Okay, so I solved one equation for a variable, and I substituted that stuff, the stuff that that variable is equal to, into the other equation for that variable. And now I can finish solving for y. So I'll have 6y minus 30 plus 5y equals 25. And combine my y's here. Remember, they're on the same side of the equation, so I'm just going to add them. 6 plus 5 is 11y minus 30 equals 25. The only time I do the opposite is when I'm moving across the equal sign. So here, when I'm trying to combine the 25 and the negative 30, I have to do the opposite. I have to add the 30 over. So 11y equals 55. And then if I divide by 11, I'll get 5. Okay, then I'm going to take this and I'm going to substitute the value for y into any of my equations, either the original top one or the original bottom one, or the bottom one that I resolved for x. That's where I'm going to substitute because it's already solved for x. So x equals 2y, and instead of y, I'm going to put the 5 minus 10. So that's 10 minus 10. So x is 0. Uh-oh, I got 0. I must have done it wrong. Oh no! No, it's okay. 0's a number. We did it fine. Okay, so 0, 5 should be my solution, but I'm going to check it and see. Okay, so if I put 0 in for x, 3 times 0 is 0. And y is 5, so 5 times 5 is 25. And 25 plus 0 is 25. Okay, the other equation, let's see, x was 0. And then negative 2 times 5 is negative 10, and negative 10 equals negative 10. Good. Okay, so it is a solution. Okay, so example A that we did, example number 1, part A, that's an example for if you're given a problem that's already solved, that has an equation that's already solved for a variable. But part B and part C, these are the problems where you have all the work to do, where you have to solve one of the equations for a variable. Okay, and our last example then is a word problem. And here, in one day, a movie theater collected $4,275 from 675 people. The price of admission is $7 for an adult and $5 for a child. How many adults and how many children were admitted to the movie theater that day? Okay, now we have to write 2 equations before we can actually start solving this. We have to write the system of equations. There's going to be at least 2 equations. Okay? Now I like to tell my students there's usually a money type equation, and then there's like a thing type of an equation. Okay? So we can see here that we've got money, we've got the total amount of money, and then we've got the price for the adults, and then the price for the children. So that right there is the money pieces of information that we're going to put all together in one equation. So if they charged $7 for an adult and $5 for a child, if they did that all day for all the adults and all the children, at the end they had $42.75. That's how much money they had. So that's how we take those pieces of the money information and put them into one equation. Now the other piece of information we have is about the number of people, the 675. They had 675 people all together. So that is all the adults and all the children. There were 675 of them. So that is going to be our system of equations. Okay, so you want to look for a money equation and then a thing equation in this case. And the thing is the people. So now if we're going to go through and we're going to solve this by substitution, I see that in this bottom equation here, both the a and the c are by themselves. So I could solve for either one of them. I'll just pick a. So if I solve that for the adults, that means I'm going to subtract c over to the other side. So 675 minus the number of children would be how many adults were at the movie theater. Okay, that should make sense. So those equations there, they're exactly the same. They're just in different forms. They're equivalent. They're just written in a different order is all. Okay? So now I'm going to take this and I'm going to substitute it into the other equation where that a is. Okay, so instead of 7a plus 5c equals 4275, instead of having that a there, I'm going to replace it. I'm going to substitute it with what a is. A is 675 minus c. So it's just like what we did in Part B and Part C in Example 1, except we have to write the equations first. Okay, so now I'm going to distribute. So 675 times 7, that's 4725 minus 7c plus 5c. Oh, now we're getting messy here. Okay, so that's going to be 4257. Once I'm able to write again, there we go, 4257. And then I'll be able to combine my like terms. So I'll have 4725 minus 2c. Remember, these are on the same side of the equation, the c's. So I'm just going to combine them as they are. I don't have to do the opposite. But now to combine my numbers, I do have to do the opposite here. Oops, I have to subtract the 4725. Okay, so I'll have negative 2c equals negative 450. And then when I divide by the negative 2, I'll get that there were 225 children. And then to figure out how many adults there were, I'm going to go back to this equation here. 675 minus the children, minus the 225, that's going to be 450 adults. So if you wanted to say that in a complete sentence, you would say there were 225 children and 450 adults that went to the movie theater. And again, we could double check that. If we took 225 plus 450, we get 675. Excuse me. And the better way to check it is probably in this top equation. Take 7 times a for 7 times 450, and then you would add 5 times 225, and you should get 4275. Okay. So these problems can sometimes be a little tricky when you're trying to write the equation from the problem. So if you have any questions on that when you're doing your homework, make sure you ask. Either come in before school or ask during class, and we can go through and we can set those up. Okay? The more you do it, though, the more you practice it, the easier it gets. So don't just get frustrated and not do it. You have to practice it. And don't forget about your exit problems as well.